All right, sorry guys, my phone ran out of space. So we're on number 3 here. I've got a segment here that's inside and outside of the circle. So for my setup, I take this outside number and I multiply it times this whole segment on the inside. So the whole segment is if I were to add 6 plus 15. I set that equal to the other segment. So here's the other one. I take my outside piece, which is 7, and I multiply it times this whole segment, and the whole segment is 7 plus x, or x plus 7. Doesn't matter which way you write it. And now this just becomes an algebra problem. So the first thing I'm going to do is my parentheses. I know if I add 6 and 15 together, I get 21. So I'm really doing 6 times 21. Just going to rewrite the rest of it here. So if I multiply 6 times 21, I get 126. And then over here on the right, I'm going to distribute this 7 to everything on the inside of the parentheses. So 7 times 7 is 49. 7 times x is 7x. And now it's just algebra. So I subtract 49 on both sides. I get 77 equals 7x. And then divide both sides by 7. I get 11 equals x, or x equals 11. There we go. We solved for x. We did what the problem asked us. Okay, number 4. Same sort of setup, but this time I've got some pieces that are on the outside and the inside, but my inside pieces happen to be some equations here. And it also asks me to find CD. It doesn't ask me to find just x. I have to find x first, and then I have to plug it into the CD. So for this green segment here, C to E, I take the outside number and I multiply it times the whole segment. The whole segment is this piece plus this piece. So it's 2x minus 7 plus this piece on the outside is 9 equals, do the same for the other segment. Outside times the whole segment, this plus this. All right, now I have to do a little bit of algebra inside the parentheses first. So before I go to distribute, I notice that -7 and 9, I can add those two numbers together because they're both constants. So if I were to add -7 and positive 9 together, I would get 7, 8, positive 2. And then over here on the right, I can add my parentheses together as well. If I were to add 11 plus 7, I'm going to get 18. And now this makes my problem a lot easier. So on the left side, I'm going to distribute 9 times 2x, 18x. 9 times 2 is positive 18, equals 7 times 18 is 126. Then I want to get the x by itself, so the first thing I do is subtract 18 from both sides. I get 18x equals 108, and then I divide both sides by 18. I get that x equals 6. Now that's great, but the question asked me to find CD. So here's C to D, it's 2x minus 7. I'm going to substitute in for x, the x that I solved for, which is 6. So I'm going to do 2 times 6 minus 7. So 2 times 6 is 12. 12 minus 7 is, CD is equal to 5. So make sure you're really careful and reading what the question asks you to find. Number 5. Solve for x, assume segments that appear tangent are tangent. Okay, so when we've got this one side that's tangent and the other side that actually goes through the circle, it's a very similar setup as before. We take the side that is all by itself, that's just on the outside, the 18, and we square that side. We set that equal to the other segment, and we set up that other segment the same way we set them up for these other ones that were inside and outside the circle. So we take the outside number and we multiply it times the whole thing. So outside times the whole is x plus 12. And then we solve it using algebra. So the first thing I'm going to do is 18 squared. That means 18 times 18. I get 324. And then on the right side, I'm going to distribute. 12 times x is 12x. 12 times 12 is 144. Now it looks easy peasy. Subtract 144 from both sides. I get 180 equals 12x, and then I divide both sides by 12. I get 15 equals x, or x equals 15. And it just asked me to solve for x, so I'm done with that problem. Number 6 looks like it's the exact same setup, so I take the one that is outside by itself, which is the x, and I square it. Then I set it equal to the other segment, outside times the whole. So the number on the outside is 8 times the whole thing is 8 plus 42, right? The whole segment, I add them together. Now it's just some algebra. So I've got x squared equals, I can add these two together first because they're parentheses. So 8 plus 42 gives me 50. I multiply 8 times 50 and I get 400. Now I've got x squared equals 400. I want to get the x by itself. To get rid of a squared, we square root. Depending what you're using, you might have to hit the shift button, you might have to hit the second button. It depends on if you're using a calculator or your phone, but since I'm using a calculator, I'm going to push second x squared, and that gives me my square root. Then I put the 400 in. If you're using your phone, make sure you have the square root that has the little 2 next to it at the bottom, so it looks like this. That means squared root. Okay, my answer is 20. Easy peasy stuff. Okay, on to the next. All right, number 7. Solve for x. Assume segments that appear tangent are tangent. Okay, so what we have is a tangent line outside that connects to the radius of this triangle. Now, wherever your radius is, and it gives me my radius is 3, that's where your right angle is going to be. And if you have a right triangle, you can solve the right triangle using the Pythagorean Theorem. A squared plus b squared equals c squared. The only one that's important is that your c squared is your hypotenuse. So if I look at my picture here, my hypotenuse is always across from the 90. So I go to the 90, I go across, the x is my hypotenuse, which means these other two sides are my A and my B. Now, I see 3.2 as one of my sides, that's good, but I'm only given the radius here is 3. The whole thing would be double that, right? Because this piece is 3 and this piece is 3. So the whole side length is 6. Okay, so now I'm going to take the 6, the 3.2, and the x, I'm going to plug it into this equation. I've got 6 squared plus 3.2 squared equals my hypotenuse squared is x squared. Doesn't matter if you flip-flop these two. The only one that's important is that your hypotenuse is the x. All right, now I'm just going to do some algebra. 6 squared is 36. 3.2 squared is 10.24. I add these two together and I get 46.24 equals x squared. And then to get the x all by itself, I square root. So if I square root that answer, I get x equals 6.8. And I solved for x, that's all I had to do. Number 8 looks like a very similar setup. I'm going to solve for x, and I'm going to assume that the segments that appear tangent are tangent. Okay, so I always look for my radius. I'm given it right here from the center to the edge. There's my radius, which means where your radius meets the tangent line, that's your 90 degrees. Go across from the 90, that's your hypotenuse. Okay, sorry. Should I crack my back? I'm sitting on the floor, guys. It's very, very uncomfortable. Okay, so I've got a side, hypotenuse. I'm going to round my answer to the nearest hundredth. Okay, so I'm going to use a squared plus b squared equals c squared. The only one that's important is your hypotenuse, which is 11. So my a and my b are the other two sides. So I've got 8 squared plus x squared equals 11 squared. Okay. Now I'm going to square my numbers here. So 8 squared is 64. I don't know what x squared is. That's what I'm trying to solve for. 11 squared is 121. I'm going to get the x by itself, so I subtract 64. I get x squared equals 57. And then to get the x by itself, I square root both sides. So I don't know what the square root of 57 is off the top of my head. Okay, so I'm rounding to the nearest hundredth, which is 2 decimal places. So I get x is about 7 point, now, 10th, 100th, 2 decimal places. I've got 54. The number after the 4 is bigger than a 5. It's a 9. So I round a 54 up to 55. So my answer is 7.55. Okay. Number 9. Find the length of EF. Okay. Now, when I have two tangent lines that share the same point on the outside of the circle, that means the two segments that attach to that point are congruent. So EF is congruent to ED. Those two are exactly the same. If they are the same, I can write an equation that says this side length, 10x minus 19, is equal to the other one, 4x plus 23. And then I'm just going to solve for x. Easy stuff. So first thing I'm going to do is I'm going to get all my x's on one side. I'm going to subtract 4x from both sides. It doesn't have to be your first move, but I like to move the x's first. I feel like it's just makes my life easier if I do that. Okay. Next thing I'm going to do is I'm going to add 19 to both sides. I get 6x equals 9, 12, 2, 3, 42. And then I divide by 6. I get x equals 7. Now that's great, but the question asks me to find EF. So here's EF. EF is 10x minus 19. I'm going to substitute in the 7 for the x. So I've got 10 times 7 minus 19. So I'm going to do 70 minus 19, and I get that EF equals 51. Nice. Okay. Number 10, find the perimeter of triangle PQR. Okay, so this is the same idea as we had over here. If they share the same point, the two sides that share that point are congruent. So I'm going to mark all of those in my picture first. The two that attach to that point Q are this one and this one. So if this one's 5.9, guess what? This one is 5.9. Another one I see is this point R out here. Okay, so the two sides that match are here and here. I put 2 tick marks now, right, because they're 2 different sides. So if this is 12.2, that means this is 12.2. And then I've got one more set point P out here, so that means this segment and this segment are the same. Now, what I notice is there's nothing given to me here, but I know the whole thing is 27.4. I've already used up 5.9, right, this red section of the 27.4. So to figure out what's left in blue, I'm going to take 27.4 and I'm going to subtract 5.9 from it, because if I do that, that's going to tell me what's left over for the blue. So if I do that, I get 21.5. So that means this blue piece is 21.5, this blue piece is 21.5. Okay, so in order to find the perimeter means distance around a figure. It's how far would I walk. I end up walking, if I'm going to go from P to Q to R, I'm going to walk 21.5 plus 5.9 plus 5.9 plus 12.2 plus 12.2 plus 21.5. So essentially I'm just going to add all of those numbers up together. So you can either add them all up or you can do 2 times each perimeter number. It's however you want to do it. I like to write it all out myself because I feel like I won't make a mistake if I do that. But it's kind of up to you. Whatever works. And then I'm just going to add together my doubles first. So if I add these 2 blue ones up together, I get 43 plus 11.8 plus 24.4. And I'm just going to add those numbers together. 43. And I get that the perimeter equals 79.2, and I'm not given any kind of like unit, like centimeters, inches, anything, so I'm just going to put units. And I have to put something because it is perimeter. Perimeter is a distance. It's how far you go, so you always want to have some kind of label if you're talking about a perimeter. All right, we are almost done. Number 11, find the length of the bolded arc. Round to the nearest hundredth. Okay, so if we are looking for the length in a circle, remember length is talking about if this whole thing is a pizza, it's like how long is the crust of this one piece of pizza right here, right? So length is, remember, you're thinking about the crust of a pizza. All right, so to find the length, we're going to do whatever our degree is, x degrees, times the circumference divided by 360. Remember, our circumference can either be 2 pi r or it can be pi times diameter, depending on whatever's given to you. What's given to me here in this picture is a radius. So I'm going to use this one. All right, so my length is equal to my degree of the arc is 35 degrees times my circumference is 2 pi r, the radius is 7.5, all over 360. So the first thing I'm going to do, I always write length is equal to, right? I always make sure I mark everything. I'm just going to multiply my numbers on the top first. And if I multiply just the numbers, I get 525 times pi over 360. So now I'm going to do 525. I'm going to press times pi. I'm going to divide it by 360. If you don't have a pi button, you can use 3.14, but the pi button is more exact, and so we always try to use the button if we have it. So my length is, we're rounding to the nearest hundredth, so hundredth is 2 decimal places. I'm at 58. The number after it is a 1, so it stays 58. So it's 4.58, and we're talking about a length, and we're in inches. Ta-da! Okay, number 12 looks similar. Find the length of the bolded arc. Now, what's different here is I tell you that this angle is 118 degrees, but I want to know the arc length over here. That's way different, right? So I have to figure out, well, what is the angle measure inside here? Well, I know the whole thing is 360, and I want to figure out what's left over of the green, so I'm going to take 360 and I'm going to take away this red part to figure out what's left over inside. So I'm going to do 360 minus 118. When I do that, I get 242 degrees. So I've got my degree, I've got a radius, so now I can do the equation. Length equals my degree, 242, times my circumference is 2 pi r, and my radius is 4, all over 360. So I'm going to multiply the numbers on the top first. I get 1936 pi over 360. Multiply times pi, divide by 360. My answer is 16 point, so it's 894, so I keep it at 89. And I'm talking about centimeters, so I mark it as centimeters. All right, just a few more, almost done. Last 3. Oops, there we go. We'll zoom out. All right, number 13. The minute hand on a clock is 9 centimeters long and travels through an arc of 252 degrees every 42 minutes. To the nearest tenth of a centimeter, how far does the minute hand travel during a 42-minute period? Okay, so you have to think about it like this. Here's my clock. Okay. If I am traveling 242 minutes, right, here's where I would start. I'd go all the way around. That's 45. That right there, if I'm traveling this way, is about 42 minutes, which is 252 degrees. It also tells me that the hand is 9 centimeters long. I want to know how far does the minute hand travel during that 42-minute period. So I want to know what is this length right here. And that should be pretty easy to figure out because we already have all the information we need. We just have to plug it into the equation. So it's x degrees. I want to know the length of it, right? So it's 2 pi r over 360. Okay, so I already know, why did I put area? This should be an L, I'm sorry guys. Length, my bad. Okay, the length is, degrees is given to me, 252, times 2 pi r, my radius is 9, all over 360. Okay, so we're going to do 18 times 252. So on top I get 4536 pi over 360. So I multiply it times pi and then I divide it by 360. I get that my length is 39 point, so it's 584. We're going to round that to be 58. And then I'm talking about centimeters, so my answer is centimeters. All right, so maybe drawing a picture, cough, cough, hint, hint, is a great idea for problems like that. Okay, last 2 problems. Find the area of each shaded sector, round to the nearest hundredths place. Okay, so now this one I'm talking about area. So again, think about a pizza. If I'm talking about the sector area, that means how much pizza do I get to eat? That's in here, the area of it. So since we're talking about area, my equation's different. Its area equals, it's still the x degrees times, this time it's pi r squared because that's how you find the area of a circle, and then I divide it by 360. Okay, I'm given the degree measure for this area, right? I'm already given that degree, it's 119, times pi r squared. I am given KL is 20. That's a radius, so I'm going to do 20 squared. Then I'm going to divide it by 360. First thing I have to do, order of operations, is I must do 20 squared first. So it's 119 times pi times 20 squared is 400. Do that all over 360. Okay. So times 119, I get 47600 pi over 360. So I multiply times pi, divide by 360. My area equals, I'm going to round to the nearest hundredths place. So I do 415 point. So I'm at 38. The number after is an 8, so I round up to be a 39. I'm talking about feet. So my answer is feet, and because it's area, it must be squared. All right. This is it, our final math problem together, guys. Get so excited. All right, find the area of the shaded sector, round to the nearest hundredths place. Now, this time I tell you that this angle over here is 87, but that does not help me with this angle over here, because this is the angle I want to know, right? Because this is my shaded sector. So I know the whole thing is 360 degrees. If I take away 87 from the 360, that will tell me how much is left over in shaded. My answer is 273 degrees. So this is 273 degrees on the inside here. Now, YZ is 14.2. YZ, that is the radius. So I have enough information and I can plug it into the equation. I've got area equals my degree, 273, times pi r squared. My radius squared is 14.2 squared. And then I divide that by 360. Okay, knowing that order of operations, I have to make sure I do this first. So I get 273 times pi. So 14.2 squared is 201.64. I'm going to take that number, I'm going to multiply it times 273. I get a very, very large number. I get 55047.72 pi over 360. So now it's just my calculator. I take that number, I multiply it times pi, and I divide by 360. Okay, so I get my area equals, round to nearest hundredths, so 480 point. It's 38 with a 1 after, so it stays 38. I'm talking about meters, so my answer is meters. And because it's an area, it is squared. All right, guys, that is it. We are finished with our video. It's kind of a bittersweet moment here. That was it. That's all the math I'm going to teach you. So now from here, if you're done with your study guide, you can turn it in, and then you'll take your quiz on this information on Thursday. You'll have Thursday and Friday to complete this quiz. The 21st, it'll be due on the 22nd at midnight. And that's it. That'll be your last assignment. The week after this will just be optional makeup work. So if you are happy with your grade after I put your grade in for this test, if you are really cool with it and you don't want to do any of the extra makeup work, you do not have to. It is all optional and it will only help you. So we are finished. Thank you again for being such great scholars. Love you all, miss you all, and I hope you guys have an amazing summer. Please reach out to me if you're chilling and you want to just say hey and you miss me. Okay? All right. Bye, guys. It's been a fun year. Miss you all. Bye.